All right, so now what we need to do is start working on some geometric applications of the algebra skills that we've been taught. And the first type is a perimeter of a rectangle word problem. Again, we've done a number of these so far. So this is just kind of review. Remember, always draw a picture of a shape first whenever you have a geometry type of situation and start filling it in to help you understand things better and get a concrete feel for what's going on. Go ahead, get started. We'll do stop and start, and I'll go over this one with you in just a minute. All right, so now, first we draw a picture, and it says here that the length is 3 less than 7 times the width. The length is 3 less than 7 times the width. Remember, with less than, first shall be last shall be first. So the 3 goes last, and the 7 times the width goes first. So altogether I have 7w minus 3. And the entire distance around this rectangle is 138. But remember, as there's a 7w minus 3 on top, there's also 1 on the bottom. And as there's a w on the left, there is also a w on the right. So the definition of perimeter is for all 4 sides to add up to the perimeter, which in this case is 138. So if I get my w's together, 1w and 7w make 8w, and another one makes 9, and another 7 more makes 16 w's. 3 negatives and another 3 negatives is negative 6, is 138. Add 6 to both sides, I get 144. Divide by 16, and I get w is 9. So the width is 9, and the length is 60. How do I get a length of 60? I just plug the 9 back in here. 7 times 9 is 63. Minus 3 is 60. So plug the length back into, plug the width back into the expression you have for the length to give you the length. Area of a rectangle we know is length times width. So I simply do 60 times 9 and I get 540. Okay, so that's a perimeter question, and I think you should be pretty comfortable with that. We've done probably 10 of them, 8 or 10 of them by now, maybe more. Then we started working on the 3 angles of a triangle. Now, do you remember what the 3 angles of a triangle always add up to? They add up to 180 degrees. So what we would like to do now is draw our picture, and in that picture, one angle is 3 times another, so that's n and 3n, and the third angle is 12 more than twice the smallest, so that would be 2n plus 12. So there are my angles. One angle is n, the other is 3 times as large, which is 3n, and the other is 12 more than twice the smallest angle, so that's 2n plus 12. You know they add up to 180. Go ahead, take it from here and do a little stop and start. I'll give you the correct answers. Okay, so I think you had time to get that done. Here's your first angle, n. Here's your second angle, the 3n. And then the 2n plus 12 is the third angle. They all add up to 180. Once you have the equation set, we always look, is it same side situation or is it opposite side? At first, and you look for same side first. At first, I see same side, and 1n and 3n are 4n's, and 2 more n's make 6n, plus 12 is 180. Subtract 12 from both sides. 6n is 168. Divide by 6, and I get n is equal to 28. Well, we talked before about how one of the beautiful things of mathematics is that we can confirm our answers. And in fact, we can arrive at an absolute definite answer. You know, in the worlds of history, if you read a book on anything historical, World War II, some political race, anything else, the perspective of the author definitely affects what we think of as history and what might have happened. And you really can't prove any of it. But in mathematics, we can absolutely prove with certainty that what we say is the answer is. And here's a really good example of how to do that. So the first angle is 28. There it is. The next angle is 3 times 28. That works out to be 84. And the last angle is 2 times 28 plus 12. That works out to be 68. And if I take the 28, the 84, and the 68, and I add them all up, I get 180 degrees. So that's proof that I did all of my work correctly, and I could hand in the test or a quiz and say, hey, I know I got that one right. In fact, when I was a student in high school even, I used to do a quiz or a test, hand it in, and before I would hand it in, because I did pretty quick work, I would check as many answers as I could, and I'd say, okay, well, let's say that there were 20 questions worth 5 points each, and I checked 18 of them right. I'd say, look, I know I got at least a 90. I'm not sure. I couldn't check the other two, so I might have gotten them wrong, or I might have gotten them right. But I know I got at least a 90. All right. So by checking, we can confirm that the work we did was correct. All right. Next up, two supplementary angles are in the ratio of 2 to 3. Do you remember what supplementary means? Supplementary is two angles that add up to 180 degrees. And whenever we see this phrase in the ratio, this was something we did in our last lesson, and we introduced the concept. We think X or N, whatever you want to say. So we think 2X and 3X as soon as we see that word ratio. The X representing whatever the thing is they share in common, that forms the ratio. So with that information in mind, we'll stop and start. You begin this one. Go ahead. Okay, so what we have here is that the two angles are 2n and 3n, because that's the n being the thing they share in common in their ratio. And because it says they're supplementary, I'm going to add up to 180 degrees. So 2n plus 3n is 180. Same side situation, 5n is 180. Dividing by 5, n is 36. But they don't want the 36. They didn't say, tell me what n equals. They said, find the measure of the largest angle. The largest angle is going to be the 3 times n angle. So there are two angles. One is 72 because it's 2n, or 2 times 36, and the other one's 108 because it's 3 times 36. So the answer is 108. And I list the 72 and the 108 because, again, if I check real quick, we add up to 180 degrees. All right. So these types of questions we've done in many problems, going back probably for 2 or 3 weeks. This is a new term, isosceles. Now, what does isosceles mean? Isosceles means it's a figure. Usually it's a triangle, but it could be a trapezoid, where you have the legs congruent to each other. Now, what are the legs? Well, if you take a look at this triangle, okay, you will see as you look at this triangle that these two sides with the numbers next to them here, okay, those two sides are the legs, and this base is what we call the piece down here, okay? In an isosceles triangle, the legs are congruent to each other. That's what these little black marks mean. And also the angles down here at the bottom are congruent to each other. Those are called base angles. So let's start with finding the sides, so I make them congruent to each other. So that means that 4 times n minus 3 must equal 2n plus 16. And we know that what we have to do is distribute the 4 before we go any further. And I distribute the 4, and I get 4n minus 12 equals 2n plus 16. And then I do, this is opposite side, opposite operation. Subtracting the 2n, I get 2n minus 12 is 16. Add 12 to both sides. 2n is 28. Divide by 2. N is 14. Okay, so that tells me that's the correct answer. Now, again, in math, we always like to confirm these things. If I do 2 times 14 plus 16, I get 44. If I do 4 times 14 minus 3, all I'm doing is substituting the value of 14 in for the n's here. I also get 44. So that shows that the two sides are congruent, so I know I did it correct. It's a check of sorts. Now, remember, the second part of this particular equation shows that the two base angles are 4n minus 9, and we already knew that the top angle, we call that top angle the vertex angle, the one way up at the top. And it could also be on the bottom if I flip the triangle upside down. The vertex angle is the angle that's not one of the equal base angles, okay? And we know those three angles are going to add up to 180. So n plus 4n minus 9 plus another 4n minus 9 has to be 180. Same side, same operation. That's 9n minus 18 is 180. Adding 18 to both sides, I get 9n is equal to 198. Dividing by 9, and I get n is equal to 22. Okay? So, since n is equal to 22, I can then check it by doing, well, 4 times 22 minus 9 is 79. And that would mean that the 22, which is the n for the vertex angle up here, and the two angles that are each 4n minus 9, they're each 79. And if I check it out and I do 22, 79, 79, add them up, I get 180 degrees. And that's correct, okay? Let's do a little stop and start on the same exact question with the numbers changed, okay? All right. So, same diagram. The two legs have to be equal to each other. So, 5n minus 3 equals 2n plus 6. Distributing. Opposite side, opposite operation situation. 3n minus 15 is 6. Add 15. 3n is 21. Divide by 3. N is equal to 7. I can plug the 7 back in over here for the n minus 3 in the parentheses and for the 2n in the one on the right, just to make sure they're equal. So 2 times 7 plus 6 is 20. 5 times 7 minus 3 is 20. Yes, they're the same either way. Now, it says number 2, the base angles of an isosceles triangle are each 20 more than 3 times the vertex angle. Don't forget that vertex angle up there is n. The base angles are 3n plus 20. And we got to add them up and set them equal to 180 degrees. You take it from here. Okay, assuming you did your stop and start and you started it back up again, that would be 7n plus 40 is 180. Subtracting the 40, 7n is 140. Dividing by 7, I get n is equal to 20. Substituting in for the angles, 3n plus 20 works out to be 80 because 3 times 20 is 60 plus 20 is 80. And 20, 80, and 80 are 180. So those are some geometry applications of algebra. This will be the third video in the series. One more to go.